Okay, so the sharing looks like it's working. Welcome. My name is G, and today Nick and I like to do a very short session demo to show you the work pipeline to how to processing 5D microscopy data in Fiji. So this relies on software we developed and called TrackMate-Lacss. So I'll briefly go over. So what are we going to do today? So this is not going to be very hands-on involved, doing a lot of things kind of workshop. But you're welcome to follow along as Nick going through the pipeline. And if you look at the chat window, there's already, we posted the data link where you can download. So that would be the data Nick is going to use, as well as sort of the server information and some other link to the documentation that you can take a look. But you're welcome to use, don't download data at all. You can, if you have some microscopy data on your own computer, feel free to just use that, load that into your current computer installation. Everybody assume already have Fiji because this is the type of workshop where I assume you come to this meeting, then you already have Fiji installed on your computer. All right. So mainly today we're gonna cover some capabilities of this software we call LCSS. So what it is, it's a deep learning model. Essentially, it's a deep learning model for single cell detection segmentation. So there's quite a bit in the last couple of years that is the dominating methodology for people interested in analyze microscopy data for single cell analysis detection for image analysis. But this particular software, we trying to add a few things that is that common, still not that common yet. The number one thing is that which this model is built from ground up as a multi-modality model. It works on both 2D and 3D data, and it handles multi-channel. Up to 3 channels. You can process up to 3 channels of the input data simultaneously, but you can also work single channel data if you want. For the user perspective, probably the most important thing is it is a server client architecture. So you don't have to worry that much about set up sort of a computer environment that can perform deep learning model execution. Instead, you can just use a cloud server that is already set up. We have an open server running. And so if you don't have that much data to process, you just connect to the open server and start processing your data. Or you can deploy your own model if you really have a large amount of data you want to process. You have a lot of users, so you can set up a Linux machine and a few command line code, and you can have your own server deployed, and you can even tweak the model to fine-tune model to whatever the final data you're interested in, and deploy a custom model. And so the next feature that we try to bring in is a much more fully integration with Fiji ImageJ, and also with TrackMate. This originally is developed for with the emphasis on analyzing time-lapse data. And so we worked with TrackMate team and designed a specific detector for TrackMate. So we'll show you how this pipeline works. And finally, this model is faster than you think. It's probably faster than other. If you have tried other deep learning models, you probably notice this one is faster than other similar softwares. So today's, I need to do it here. Right, so what are we gonna do today? We have a very short session. So we're gonna just go through a few very simple things. We don't have time to go through a lot of the, TrackMate is very, very functional, rich plugin with many years of development. We don't have time to go through everything. Instead, I encourage you to go to tomorrow's the morning session, unfortunately at 4 a.m. That would be much more focused on a lot of user GUI element of TrackMate. Today, we don't have time to do that. Instead, we're just going to focus on the cell detection element. The first thing a lot of people comes in when trying to use the deep learning model, the first question is, how do I know if it works on my data? So we're going to show you some installation-free test just using a cloud server. And then we'll show you how to do start segmentation just with a few clicks in Fiji. Then I'll show you, then we'll do a demo with how to integrate with TrackMate, how to run this detection within TrackMate, the wizard system itself. And finally, we'll show you a bit with how it works with the 3D time-lapse data. So that's everything we're going to do today. These are the information you need if you want to follow along the demo. So the top is the server, open server for this model. Unfortunately, today I encourage you to use the alternative server because our main server has usually a software demo goes they usually went down at the time you need them. But the alternative server is still running, so everybody should connect to the alternative server. So if you're not doing steps by following the whole thing, I will encourage you to take a look at the websites, the GitHub website of the software that's used today. And there's a lot of documentation there, as well as instructions on things we cannot discuss today, such as how to set up your own server. Okay, so with that, I'm gonna stop and transfer it to Nick.
Hello, everyone. So we're going to start off with just the website that we developed on the cloud to test your own data real quick, just in case anyone wants to follow along with their own data. Let me share my screen. So there should be a link in the chat that links to Hugging Face, which brings up something like this. So this just gives a quick example of what the model can handle. So it can handle some H&E stains. This is like a peripheral blood smear, standard bright field, fluorescence. Sorry, this is a bit zoomed in. Fluorescence, and of course, some bacteria. So unfortunately, there's some limitations with this cloud that it only handles PNGs and JPEGs. So you might have to convert your TIFF file to something before you upload it to this test. Also, it's on CPU, so it might be a bit slow. But moving on to the actual plugin, we'll move on to ImageJ. So these are a bit spoilers, but I'm assuming everyone here has a standard image or Fiji installation. But to get the plugin, it's a standard update or standard installation for every other plugin. So we'll click the help into the update, and then it will pull up this updater, of course. And then you move on to manage update sites. And then if you search up LACSS, it should be just right there. We'll click it, and then it should install two packages, I believe, a segmentation and the actual TrackMate LACSS, which will implement itself as a detector for the TrackMate plugin. So we're just gonna very quickly exit out of here as it's already installed. So for today's little demo, I provided a data set from the CTC, the Cell Tracking Challenge, which is just a publicly available data set. And I cropped it just for the time convenience sake. But as you can see, it's a 92 frame movie, and it just goes through with some mitotic events, really. Just quickly skimming through it. But back to the front. For this plugin, we have two main things beyond, or one main thing beyond the TrackMate. So the first thing is you would go to the plugins and segmentation. You should have a box after installation called LACSS, of course. This is where it brings up the parameter prompt. So if you're following along right now, this LACSS server is where you would put in the IP we provided. Where's my? So this is one of the IPs I think we provided, the alternative server, which is what we recommend for as any server client model or server and client architecture. You usually would require a password for privacy sakes, but for today's demo, of course, we just left it open, so nothing's required there. So the LACSS model generally has 4 parameters. The first is min cell area. And this is really just an exclusion parameter. Sometimes your data set has obviously some smaller cells or some artifacts that you might not want to include into your data set, into your results. So that's just an exclusion parameter. But we'll leave it at default today. Min score is related to the detections. It's as it sounds. Each detection or object that's found by the algorithm is given a score from 0 to 1. So depending on how stringent or how lax you want your detection to be, you set it from 0 to 1, of course, with 1 being a perfect, which is essentially impossible, and 0 being, of course, as loose as possible. But for today, we have default at 0.4. Scaling is more of a complex parameter. If anyone's used cell posts here today, it's very similar to what they consider a cell size, from my understanding. And it's really just a sort of expected pixels. The model is trained on certain images with an expected cell size. So, for example, depending on your images collected, sometimes the resolution is larger, smaller, etc. So this is just a way to give a hint. It's not an absolute, but it's a hint for the model to know what it's generally expecting for a cell resolution. But for today, we'll just use a 1, which is default, normal. And NMS IOU is another parameter for post-processing. It considers situations where 2 cells are kind of two detections, are overlapping. Maybe it's a clumped confluent environment, or it's in the middle of a mitotic event or something like that. So if you set it to 1, it'll be on, of course, and it'll try to eliminate one of the 2 detections. But since the data set that you can see on the right isn't very complicated, we'll just leave it at 0. But if you press OK, okay.
Is your server address correct?
Did we change it?
No, I mean, just saying normally this is not a server you normally use. Did you type it correctly?
Okay, this is bad. It should be the 1.
You haven't got a chance to test it today?
Actually use just give me 2 seconds. Bring up the oh, so that the IP did change. The alternative server might be down, Dr. Yu.
No, I don't think so. You sure?
Yeah, I think it's down.
All right.
So unfortunately, that one might be. Yeah, I think it's down.
Okay, so can you connect Mantis?
Yeah, I'll use Mantis. This is so unfortunately, we'll have to use one of our private servers. And then after pressing OK, it'll generate some region of interest of cell detections. As you can see, as I scroll through it, it'll highlight expected cell detections, show all of it. And segmentation only does the first frame or whatever frame we were on. But that is a general way to just check the detections and export it if you're not interested in the time-lapse features that TrackMate would offer. But moving on to the TrackMate features, discard these. So we'll have the same data set as above. This time we'll use TrackMate. So we'll go to plugins, tracking, and then TrackMate. This is the standard TrackMate that the TrackMate group developed, of course. Everything is pretty standard, and we again recommend you attend the TrackMate session if you're interested in what TrackMate has to offer. But everything is very standard of our procedure. The first stage just detects your opened data set, really. But if we go to next, we'll see the list of detectors. Many different detectors have been implemented into TrackMate. And there, of course, CellPose is here, and there's a couple other ones from other groups. But after installation, you should see an LSS detector. Which we would select. And then we would click next. Again, the same parameters are available. Multi-channel is an extra parameter in the TrackMate, which, as it sounds, considers multi-channel data if you have it. If we click preview, it should do the same thing as the segmentation thing, but it'll provide some extra TrackMate related data, really, the histogram of scores. But if we click next to proceed through the entire, you actually see some of the perks that we mentioned before, that our LICS model is actually very fast, even with not the highest end backend. I believe the stats are 5 seconds per image, right, Dr. Yu?
No, 5 frames per second.
Sorry, 5 frames per second. And then, again, these are TrackMate's features that allow some of its own score thresholding. We'll just take all of them for now. And then it'll display everything. And then as we slide through it, we'll see all the detections. Again, these are TrackMate features, not our features. Yeah, and of course, we took all the detections and we didn't eliminate any. And again, this is where, again, we recommend TrackMate because it has that extra filtering, as well as you can individually delete the ones that are outrageous, which again is the benefit of integrating into TrackMate. And then beyond this is actually the TrackMate features again. So. Okay. Should I go into the 3D data or?
I can do the 3D part. All right. So I don't know if any of the audience today here following along or not. So if you have was able to follow so far, or actually was able to connect to the server with your own data set, you can let me know. If you have trouble connecting for either of the current 2 open servers, let me just double check if I posted things correctly. But I said that the information is in the chat window. 35, 184, 90. 6, 93. Yeah, it should be running. I just checked, it's running. Okay, hopefully it's running for you guys. But normally, really, the server you should connect to is the one that wasn't that difficult to remember. It's lcass.cam.uchc.edu. This final number is the default port number. It's that usually doesn't change. We always open, the server is always receiving connection at the port 50051. I said this model does both 2D and 3D segmentation, cell detection. So I'll do a quick demonstration of how it works on 3D data set. So I'm going to share probably my, how do I share whole screen? Sick. Desktop share. Right. So this is I already opened the data. So this is again the open data set. This is basically a fluorescence image of a small organoid. So open it as a hyperstack. This is typically what you want your data to show up in Fiji or ImageJ. Is that for high dimensional data? This one has only one channel, but if you have both time channel and the stack channel, you want to first format it as a hyper stack. This would allow TrackMate to handle it much better. If you are trying to install this software and running it right now on your own data, I'm going to warn you that you might not see everything the same as what I'm showing on my screen because I'm running the developing version. Some of the feature it's showing on my screen is not on your installation yet, but those will be released soon. So in this data set, as you can see, it's a fluorescent image of a confocal image with about 140 stacks, Z slices. And if you go through the dimension, as you can see, it's just a clumps of cells from an organoid. Then there's another clump on the corner of the field of view. It's not that complicated. Then there's a time dimension. Going through the time dimension, the thing's just wiggling around a little bit. So not a particularly complicated data set to analyze, but still, because it's in 3D, perform a full segmentation can still be very tedious. So we'll go through, see how TrackMate and LCS handles it. If you open TrackMate, the first screen is, if you have used TrackMate before, you have seen it before. It tells you, just summarize how many dimensions and the size of each dimension, just to confirm that it understood the data correctly. So this is, as I said, if you format it as a hyperstack, usually it should doing pretty well. And go to next. Nick has already shown you, you need to select this particular detector that we are using. So I'm running the developer version, therefore I have more log information than you are, so ignore that. All right, then you need to, again, put the server address. You can use for once hours, as I said, our typical standard open server is lcss.cam.uch.edu. I'm running an internal server here, so my address is slightly different. Nick already explained to you all the parameters. Those really, so I'm mostly running just some standard parameters. The multi-channel, because I only have one channel, so I haven't checked the multi-channel ones. You can always just make a quick detection to see how does the preview look. So in 3D, it should show up segmentation of each cells. It may not be very easy to see on your computer, but it shows up. There are 4 cells here. There's 2 dots represent the two cells that's invisible, but it's there. But if you scroll through the slices, you can see now it will change to a real segmentation when you go into the real places of where cells are. Typically, at this junction, I would for 3D segmentation, I prefer to recolor the coloring scheme. Well, the default of TrackMate is the coloring scheme is every segmentation, every cell is labeled with the same color. A very useful thing for 3D is just color based on Z, based on is it on the top of the 3D stack, on the bottom of 3D stack. So if you color based on Z and auto scale it, and it should show. So for example, red really means it's at the bottom and the green is on the top. So this is at this window, there's this setup icon, this switch to the setup system, and you can change that. It's one thing I would typically want to do, so make things much easier to see. Now you can scroll through the Z slice and see the segmentation correctly. The newer version also provide a 3D view. This button may not be there on your computer yet, but this is really what we have planned feature for the next release, where you now can see the segmentation in 3D. Okay, so I'm going to close it, and actually, I would normally change the display setting a bit. I'm going to draw the field. This just makes things a little bit easier to see. You don't have to do this for your data, but I like to view it this way. And then the procedure is the same. The rest is really exactly the same as what you normally would work on a 2D data set. Once you're happy with the current parameter setting, you go to, you run the detection frame by frame through the whole movie. And then you should be able to see the segmentation for cells for the whole time-lapse data set. So the 3D data detection, it will be slightly slower than 2D for very simple reasons, because we're not looking at individual 2D images anymore. So it's a much larger amount of data. Even for each individual time point, you have a lot more data to process through. But still, this is a very short movie, so it doesn't finish. Doesn't take that long to finish. So then you do the same thing. You need to, if you want to gate the various different type of features, you can gate them here. The first feature you look at is always quality. Then there are other features you can set. And today we're not going to do any filtering here. Just simply go through the whole procedure, and then you can select a tracker to finish the tracking, right? So at any time of the point, you can always go to this view window and look at your 3D view of how the current segmentation looks like at the current frame. So this is just to visualize how the segmentation works with the 3D rendering engine. This is rendering on your computer, not on back end. So it depends on the rendering speed. It does depend on whether or not you have a display card that can do some kind of rendering or not. But typically, this does not require that much computational power, unlike the deep learning-based modeling system. So this is running on front end. And then in the end, just if you have worked with TrackMate, you would know that typically you just export your data through save, and you export everything out into an XML file. All right, so this is our short session for today. And so I guess I'm open for questions. Let me just quickly take a look. Oh, yeah. So, okay, that's the chat window. Let me just check if anybody has asked any questions. Okay, looks like, oh, there's a question in the chat. The question is, can we save the 3D view of the image? The 3D view really is a projection. So the data, if you want to save the data, exported data, each cell is exported as a mesh. If you know a little bit of 3D rendering in 3D graphics, so those are a mesh would be a standard data format to describe a 3D shape. Now the 3D view you see is simply rendering that 3D mesh through a particular view, distance angle of this. So that's sort of a snapshot of things. So that doesn't capture the complete analysis result. Therefore, you can always re-render it using any 3D rendering engine once you have the mesh data. You don't even have to use ImageJ to render it. There's plenty of 3D rendering software, that open software you can use it for once you have the mesh data. So for the open server, we do a minor amount of logging. We don't currently we don't save. So okay, the question is, are the images transferred to the server stored on the server as well? For the open server, I should have mentioned that a few limitations of the open server. Because it's still in a very beta stage, and we cannot guarantee continuous sort of funding support. So we're trying to keep it on as much as possible, but you can see there are downtime. We don't have up in 24/7 yet. And we don't log all the images, but we do some degree of logging just because for troubleshooting and for informatics data analytics purpose. But in the future, if the server capability increases, we might save more images. So that is something we cannot say for sure yet. If you care about sort of privacy, data privacy, and also if you're dealing with sensitive data, this is why I strongly suggest for people with a lot of data processing need to set up your own server. Our website, the GitHub website, does have instructions of how you set it up. It's really not that complicated. All the model parameters are open in MIT license. You can download them freely. You can tweak those models yourself, and all you need is a Linux machine with a modern GPU to start running your own server, and then you don't need to worry about any of the data security issue. And if you need help, just email us. We would be very happy to help you to set up your own server. Set up your own server also has the advantage of much shorter data transmitting distance, so your response time is going to be faster. So this is how we do. As you can see, we have our own internal server. Our own internal users, our internal server on the intranet. This is how people, for example, we support microscopy facilities, how the people on the microscopy instrument, how they can start running process while they are collecting data on the instrument, because those instruments usually don't allow you to install very elaborate software packages, but they don't need to. They just need a Fiji ImageJ there, and they can just connect to our internal server. I hope that answers your question. Anything else? All right. Okay. So as I said, we only planned for
Just one more question, Dr. Yu. Just one more question.
One more question. Where? Does it work on noisy images with diffusion fluorescence apps, or should we denoise? Well, generally speaking, deep learning type of models handles various kind of noise very well. But as I said, the easiest way for you to figure out is go log on to the demo site. If you don't have the demo site URL anymore, just go to the GitHub web page. There's a link to the demo site and upload your image. You don't need to check every of your image, but you can upload a few typical type of images and look at the segmentation results. And if you're happy with it, then you can just connect. Then you can just go to Fiji and start processing your data. If you're unhappy with it, you can do some local pre-processing if you want. Generally, in my experience, those rarely help that much. If the model does not understand your image semantics, then it's not because the image is blurring. It's because they haven't seen a cell shape like a kind of staining pattern like the specific staining pattern you had in your data yet. That's usually where the deep learning model have struggling with. So our model trained on a very, very large set of data, probably larger than anything has so far published. So so far we are very happy with its generalizability. But if your data doesn't work, if it doesn't work very well on your images, I actually would encourage you to send me your image, and we are continuously tweaking our model and trying to make it more generalizable. Right. Anything else? All right. Should we end here?
Yes. Thank you for everyone's time.
Okay. Thank you for coming.